Well, so far we've been looking at examples that have already had a common denominator, and that's kind of boring. Let's look at rational expressions that have unlike denominators. If I've got 4 and 6, this is something that we've dealt with long enough or often enough that we can look at this and say what the common denominator is. But what I want you to be able to do is to look at it from a different perspective. Like, you could probably look at this and say that the common denominator for 4 and 6 is what? 12. Well, I want you to look at this in terms of factors, because I'm going to start looking at these guys with polynomial expressions, or polynomials for the denominator, and you're not going to just look and say, here's the LCD. But if you look at the factors, it's not too bad. 4 factors is 2 times 2. 6 factors is 2 times 3. Do you all agree? Your job is to have the same denominator, right? Which means that you have to have the exact same factors for both denominators. So what we do is we put in missing denominators, or missing factors in the denominator, so they're both the same. If I look here, 4 is made up of 2 times 2. What does the denominator of 6 have that 4 doesn't have?
3.
A factor of 3. Now if I put a 3 down here, that changes the problem, right? How do I make sure that the problem doesn't change? I have to multiply that numerator by 3, don't I? What's 3 divided by 3? It's 1, which means I'm just multiplying the fraction times 1. So I'm not changing its meaning, I'm just changing the way that it looks. Like I told you, when my son was saying what's 1 plus 1, and I responded by saying the answer is half of 4, it's the same thing, just written a different way. So now that I've got 6, I've got factors of 2 and factors of 3. Well, this denominator now has factors of 2 and 3, but is there something that this denominator on the left has that the 6 doesn't have?
The 6 doesn't have another 2.
So this guy has 2 factors of 2. This only has 1. So I need to put an extra factor of 2 in here, and I also put that in the numerator. Do you all agree? So when I put these guys together, my denominator is made up of 2 times 2 times 3, because they both have those same factors, right? And you may say, well, wait a minute, the second denominator, those factors are in a different order. And what would I say to that?
Order of multiplication doesn't...
When we're multiplying, the order doesn't matter, as long as I have the exact same things. Here, a 2, a 2, and a 3. It's all the same. But in the numerator, you actually have to multiply this stuff out. So you would have 9 plus 2, and you got to finish this guy. Of course, 9 plus 2 is 11, and what does all of this stuff in the denominator give you?
12.
It's the LCD that you knew it was going to be, which is just 12. And I know some of you are saying, well, that's a really long way of doing that problem. Maybe, because you should be able to look at this and say the LCD is 12. But if I were to give you this problem, 3x divided by x squared minus 2x minus 15 plus 5 over x squared minus 9. If I look at this, and I know that I'm supposed to be adding, and I have to have common denominators, it's going to be more difficult for you to find the LCD when those denominators are not integers, but they're polynomials. But we're going to tackle this problem the same way that we tackled the first problem on this page. What did I do with the denominators in the first problem? I factored. What do you think I'm going to do now? Let's factor this. So how does this first denominator factor?
3 and 5.
The whole denominator is the same as 3 times 5.
Sorry, that's 21. Oh, what is it? 2, yeah, x.
What are the factors?
X plus 3 and then
X plus 3 and x minus 5. What about the other denominator, the x squared minus 9?
X minus 3x plus 3.
I'm going to go plus and then minus. It doesn't really matter, but you know my habits. I'm so positive, I always got to put the plus first.
You want to make me negative?
He's a negative 3.
Now I've got to look for those missing factors. What is that first denominator missing that the other guy has? Wait, what is this guy missing? He's missing the x minus 3. He sees he has that. Of course, we always want what the other person has, right? Like I want some of those hot fries.
You do?
No, I don't.
I know.
That's what in my line of work we call JK. So if I put the x minus 3 in the denominator, I also have to put that in the numerator. Otherwise, I've changed the problem. Because what is x minus 3 over x minus 3?
1.
It's 1. What is the second denominator missing?
Everything.
He's not missing everything. He's just missing the x minus 5. Right? You put that in both the numerator and denominator. Now look between these two denominators. Don't you have the same factors? They both have x minus 3. They both have x minus 5 and x minus 3. So that means I can now combine my numerators.
Are you okay?
So with my numerators, I need to distribute and combine like terms. Look at the last problem that we had. You actually did 3 times 3, and you did 1 times 2 to get the 9 and the 2. I'm going to do the same thing here. I just need to distribute. So go for it. What do you get?
Where did you get the x minus 3 from?
This denominator is made up of factors x plus 3x minus 5. This is x plus 3x minus 3. Does he have something that this guy didn't have? What factor did he not have? It was the x minus 3.
So you have to add it?
I'm multiplying it in the denominator and the numerator, like that.
So basically,
Look what you did
to
up
the
here.
bottom one, you have to do to the top.
Right, you can't just multiply something new in the denominator because it changes the meaning. If I just multiply this denominator times 3, that would have changed my problem, right? But by multiplying the numerator by 3 as well, I multiply by 3 over 3, which is 1. If I were to just go in the computer and divide your grade by 3, you're going to be upset, right? But if I divided it by 3 and multiplied it times 3,
Okay, the same.
it would be the exact same thing. Putting it in the numerator and the denominator makes it look different, but it's still the same. Same thing here. I was missing the x minus 3. This guy had it. He did not. So now I'm going to distribute so I can worry about my numerators now. The denominators are set. They are the same. So when I distribute, what do you get?
3x squared minus 9x.
3x squared minus 9x. And what about this?
5x minus 1.
It's going to be plus 5x
Doesn't that pins?
and minus 25.
Oh, is it wet? Yeah.
Am I done here?
You can combine like terms.
I can combine like terms correctly, right? When I combine like terms in the numerator, what do I have?
3x squared minus 4x minus 25.
3x squared minus 4x minus 25. I keep my denominator because I haven't done anything with that. Now you may say, do I need to multiply out all those factors in the denominator? And the answer is no. You really want to keep those guys factored because when we see these expressions later on, it's going to be better for you to have them factored so that we can get more information out of it. Otherwise, if you multiply it out, you're probably going to need to have it factored back again. So why would you do that? Now this numerator, you can try to factor this. I'm going to tell you right now that he doesn't factor. Now, you may not believe me, so I want us to try to factor this on our own. If I took 3x squared minus 4x minus 25 and I try to factor that using the techniques and the strategies that we've talked about. Is there a common factor for all of this?
No.
Nothing other than 1. It's a trinomial, so I expect it to break down in 2 sets of parentheses. How do you expect 3x squared to break down?
3x and then x.
Do you really have a choice on that? No, because 3 is prime. If I look at 25, the factors are 1 and 25 or 5 times 5. What's neat about that?
You can eliminate 5 times 5, but it will not work.
Why not?
Because there's a common factor of 5 and it will not go into 4.
They have a common factor of 5 that does not go into 4. I don't use that at all, so I have to use 1 and 25. If I do 1 and 25 like this, look at your outside and inside pieces. Outside is 75, inside is 1. Will that ever give you a 4?
No.
No. So maybe I meant to put a 25 here and put the 1 here. Does that work out?
No.
That gives you 25x and 3x, and no matter how you put your signs, do you ever get 4x? No. So what we know here is this guy is prime. So we can try all we want to, but that numerator is not going to factor, so we're going to be done with that guy.